All right, we've got this spec sheet here for a Snap-in M88P connector. And I gotta say,
Yeah.
just looking at it now, it's a little bit dense.
Yeah.
So what exactly is this thing?
Well, imagine you're building like a robot
Okay.
for a really harsh environment, like a factory floor or,
Mm-hmm.
even like exploring another planet.
Yeah.
And you need to connect all the different
Oh, yeah.
sensors and lights and motors and stuff.
Right.
It can't be
Yeah.
just any connector. It
Yeah.
has to be super durable,
Right.
resistant to like dust and water.
Uh-huh.
So that's kind of where this Snap-in M88P connector
Okay.
comes in.
Interesting.
It's kind of becoming the go-to solution for engineers
I see.
who need that reliability.
Yeah, that makes sense.
Yeah.
So this Snap-in part of the name,
Yeah.
it sounds really simple and easy to use,
Uh-huh.
but this spec sheet here makes it seem like
Yeah.
there's a lot more to it.
Yeah, absolutely. The snapped-in part is definitely convenient,
Right.
but it's really all about the ruggedness.
Okay.
Like this IP67 rating we see,
Mm-hmm.
that means it's completely sealed
Oh, wow.
against like dust
Uh-huh.
and can even be submerged in water.
Oh, that's cool.
Yeah.
So it's like a tiny waterproof
Yeah.
little vault for electrical signals.
Right, exactly.
Okay, so what kind of power can this thing handle?
Yeah, so it says here it has a 2 amp current capacity.
Okay, is that a lot?
Yeah, it's enough to power a surprising amount. Think of like small sensors,
Mm-hmm.
LED lights, maybe even some low power motors.
So that's pretty significant then.
Yeah, it is.
Wow, this is really interesting.
Yeah.
I'm starting to imagine these things everywhere,
Uh-huh.
like quietly working behind the scenes,
Yeah.
all kinds of cool stuff.
Right.
Now, this document mentions a pretty impressive operating temperature range.
Oh, yeah.
I'm looking at it right now.
Yeah, so it can go from negative 40 degrees C to plus 105 degrees C.
Wow, that's a huge swing.
It is.
So we're talking about like Arctic conditions to like a scorching desert,
Yeah.
and this tiny little thing can handle all that.
Yeah, it's pretty crazy.
That's wild.
Yeah.
How do they even,
Right.
what makes that possible?
Well, it's all about the materials and the design.
Okay.
So the spec sheet here says they use copper alloy contacts
Uh-huh.
with gold plating for good conductivity,
Mm-hmm.
and they even use silicone O-rings for sealing.
Oh, wow.
Yeah, they really thought of everything.
So they were very meticulous about this.
Absolutely.
Okay, but it's not just surviving the extreme temperatures, is it?
Oh, you're right.
This thing has to endure all kinds of abuse,
Right.
like if it's out in the field.
Exactly.
And that's where all this testing comes in.
Yeah, and there's a lot of it.
I see that here.
Like, for example, they have this cable pull-out test
Okay.
where they actually yank on the cable with a force of 222 newtons.
So how much force is that?
That's about 50 pounds of force.
50 pounds
Mhm.
on this tiny connector.
Yeah, and it has to withstand it without breaking.
Oh, way.
Yeah.
So it's like a tiny little strongman competition.
Yeah, pretty much.
Only the toughest survive?
Exactly.
Wow.
And there's more.
Okay.
They also do this cable flexing test
Hmm.
where they basically bend the cable back and forth
Huh?
hundreds of times.
Yeah.
Yeah, simulating years of wear and tear.
Okay.
And then, get this, they do this thermal shock test.
What's that?
They go from freezing to boiling.
On this tiny connector.
Yeah.
Wow.
Crazy, right?
That's wild.
Yeah,
So they're really putting this thing through the ringer,
they are.
and it's all to make sure it can survive
Yeah.
out in the real world.
Exactly. That's the key takeaway.
Right.
It's not just about passing a test.
Right.
It's about making sure it works in the real world.
Right.
Like in a factory
Hmm.
or on a wind turbine.
Right.
Or even like, a Mars rover.
Wow.
That's the level of reliability they're
Mhm.
going for.
That's incredible.
Yeah. And that's really driving a lot of innovation in different fields
Yeah.
with like industrial automation and robotics.
Okay, so we've got this picture of a tiny, durable connector
Yeah.
that can handle a lot of power
Uh-huh.
and survive in some pretty harsh environments.
Right.
So where are we seeing these connectors being used today?
Well, you can find them pretty much anywhere you need those connections in those harsh environments.
Okay.
Like, industrial automation's a big one. Like factories
Um,
with robots.
Yeah.
All the machinery.
Sure.
They need sensors for like everything.
Yep.
And those connectors make sure that they can
Keep working,
keep working.
no matter what.
Right. Exactly.
Okay, so it's like the nervous system of the
Yeah.
factory,
Yeah, pretty much.
keeping everything running.
Exactly.
Wow.
And, you see it in outdoor lighting too.
Oh, yeah, like what?
Like, street lights,
Okay.
stadium lighting.
Yeah.
Even those like illuminated signs you see.
Right, those big billboards and stuff.
Yeah, exactly.
Okay.
And the Snap-in M8's perfect for that.
Right.
Because it can handle, you know.
The rain, the snow.
Yeah.
All that stuff.
Okay. What about all those smart city initiatives we hear about all the time?
Uh-huh.
I bet these connectors play a role in that.
Absolutely, yeah.
Okay, how so? Well, as cities get smarter,
Yeah.
they need more and more sensors
Uh-huh.
to monitor like air quality,
Okay.
traffic flow, energy usage, all that stuff.
Right.
And all those sensors, they create a ton of data.
Sure.
And the Snap-in M8 provides that reliable connection to get that data where it needs to go.
Wow, that's amazing.
Yeah.
Something so small can have such a big impact.
Exactly.
Now, this spec sheet here mentions a 24 AWD gauge for the wires.
Uh-huh.
Is that important?
It is, yeah.
How so?
Well, so AWG stands for American Wire Gauge. And it basically tells you how thick the wire is.
Okay.
And 24 AWG is relatively thin.
Okay.
Which is important for a small connector.
Right.
So they had to find a good balance, you know, between size and being able to handle the current.
Right, so it can actually power things.
Exactly.
Okay.
And they didn't just stop there.
Yeah.
They also made sure it's safe.
Oh, okay.
Like there's this dielectric withstanding voltage test.
What's that?
They basically zap the connector.
With how much?
500 volts.
500 volts?
Yeah, for a whole minute.
Wow, and that's safe.
Yeah, it's all about making sure the insulation prevents any shocks.
So it's like a built-in safety net.
Right, yeah.
Okay, so they're not taking any chances
Nope.
with safety.
Not at all.
And that goes for the harsh environment stuff too, right?
Absolutely.
Like this salt spray test.
Oh, yeah.
It says here they expose it to a salty mist
Uh-huh.
for 48 hours.
That's right.
Seems kind of excessive.
Well, think about it. You know, if you're using this connector near the ocean or in some industrial setting with all those chemicals,
Sure.
it can't corrode.
Yeah, that's true.
So 48 hours,
Makes sense.
mixture can handle it.
No, they really are putting it through the ringer.
They are.
But it's not just about the individual tests. Right?
No, you're right.
It's about the big picture.
Yeah,
Making sure it's reliable over time.
that's right.
And they have other tests for that too, right?
Oh, yeah, absolutely.
Like what?
Like, they do this temperature humidity cycling test
Okay.
where they basically subject it to extreme temperatures
Yeah.
and humidity swings.
So like going from really hot
Yeah,
to really cold.
yeah, over and over again.
Wow.
It's like a sauna and a cold shower.
You got to be tough to survive that.
Yeah, you do.
What about those tests they do on the cable itself?
Oh, yeah, they've got a bunch of those.
Like what?
Like the cable pull-out test.
Okay.
You know, where they yank on the cable, make sure it doesn't come out. And then there's the cable flexing test,
Okay.
where they bend the cable back and forth.
Simulating wear and tear.
Exactly.
So whether it's being pulled,
Yeah.
twisted,
Uh-huh.
exposed to extreme temperatures, this thing is built to last.
Yeah, it's like a tiny little action hero.
I like that.
Yeah,
Surviving all these crazy challenges.
exactly.
That brings up an interesting question for me.
Mm.
What other applications could this be used for
Oh, yeah.
in the future?
That's a good question.
Because we've talked about factories and cities,
Uh-huh.
but it feels like we're just scratching the surface here.
I agree. With
Yeah.
its size and durability and reliability, I think it could be really important for a lot of emerging technologies.
So we're talking about going beyond
Yeah.
those familiar applications. What's next for this thing?
Well,
Well, it's clear that this connector has already
yeah.
proven itself in all these really tough applications.
Mhm.
But where can it go from here?
Yeah. I mean, that's the exciting part.
Okay.
Like, think about all this wearable technology
Hmm.
that's coming out now.
Right.
We need connectors that are small and
Right.
tough.
Yeah.
And I think the Snap-in M8
Okay.
could be perfect for that.
So instead of just connecting machines,
Right.
you're talking about connecting
Yeah.
sensors directly
Uh-huh.
to us,
Exactly.
like to our clothes,
Yeah.
or even medical devices
Yeah.
that are implanted.
Yeah. Imagine that
Wow.
your clothes are monitoring your vital signs and sending that data to your doctor.
Through this tiny connector.
Yeah,
That's pretty amazing.
it is.
What about prosthetics?
Oh, yeah, absolutely.
I could see it being really useful there too.
Yeah, like artificial limbs controlled by a bunch of sensors, all connected with these connectors.
So we're not just talking about industrial stuff anymore.
Right.
We're talking about connecting with humans.
Yeah, it's pretty mind-blowing.
It is. It really is.
And it doesn't stop there.
Okay.
Think about drones. All those drones we see everywhere.
Delivering packages,
Yeah.
doing surveillance.
Uh-huh.
They rely on all kinds of sensors and motors.
Yeah, exactly. And they need tough connectors
Okay.
that can withstand all the vibration and the temperature changes.
So you think the Snap-in M8?
I think it could be really important for drones in the future.
So whether it's a drone
Yeah.
delivering a package
Uh-huh.
or a prosthetic limb
Right.
helping someone walk,
Mm.
this tiny connector is there.
It really could be.
Wow.
Yeah.
So it's not just about connecting things.
Right.
It's about enabling all these future possibilities.
It really is.
It's pretty incredible to think about.
It is, yeah.
That something so small can have such a huge impact.
I know.
It really makes you appreciate the power of engineering.
Absolutely.
And the importance of making things reliable.
Yeah. I mean, who knows what the future holds? But I think the Snap-in M8 is going to be a big part of it.
Well, you've definitely given us a lot to think about.
Cool.
It's more than just a connector.
Uh-huh.
It's like a gateway to the future.
I like that.
Well, that's about all the time we have for today.
Okay.
But I really appreciate you taking the time to break down
no problem.
the spec sheet with us.
Happy to do it.
It was a really fascinating deep dive.
Yeah, it was fun.
So until next time,
Yeah.
keep those minds curious and remember, even the smallest things
Yeah.
can have a huge impact.
Absolutely.
We'll see you next time.
Sounds good.